subtracting rational expressions. So unlike when we are multiplying and dividing, we have another issue that comes up here. And the issue is that in order to add and subtract fractions, you need a what? What do you have to add and subtract fractions?
LCD.
Common, well, I hear what you're saying, but common denominator, right? Doesn't necessarily, hold on, denominator. My spelling's awful. Okay. It doesn't necessarily have to be the LCD. It could be bigger, right? The lowest common denominator is always preferred, but it could be something bigger as long as it's common. So I'm not worried about you must get the LCD. I'm not worried about that. I just want you to have a common denominator. You're still going to get the right answer no matter if it's the lowest common denominator or you pick something larger, because we can go through and simplify. So I'm not worried about that part. All right, today we're just going to add. Tomorrow we're just going to subtract. So we can kind of compartmentalize. And then the worksheet you get on Monday will be a combo of both. Okay? All right. So take a look at number 1. Do you see how everything's all perfect and lovely and rainbows? You love when that happens. So when we have fractions that we're adding together and they have the same denominator, the denominator just carries through, yes? So for example, think even easier. Go back in time. If you had 2 fourths plus 1 more fourth, how many fourths do I have total? Right. So the bottom carries through. So the bottom still carries through even with a little bit trickier problems. But in the top, what am I actually going to do with those things? Add them. Okay. So x plus x gives me 2x. Negative 3 and negative 2. So it's negative 3 plus another negative 2. Negative 5. Now, you need to stop for a second and take a look and see if you could simplify anything. So think back to the multiplication and division. Pretend this was a plus 8 instead of a minus 5. Could I pull out a 2 and have a match and cancel things? So you always need to be on the lookout to see if you can reduce. But I cannot reduce this one. Now, before we flip, do you see where it says tell me where it's undefined? What can't x equal? Instead of writing undefined, I always write it as what x can't be. What can x not be in this problem? Negative 4, because it would make my denominator 0. So if it asks you where it's undefined, you have to explore all the denominators along the road and tell me all the things it cannot be. Okay? Now you can flip when you're ready. Okay, we're going to do 2 more examples today. Again, we are just, oh no, just kidding. I'm going to add an extra example. I'm missing something. Well, I know, but you're going to be sad. I'm going to call this example 3.5. I know. Well, you know what? We need it, though. Otherwise, when you get to the homework, you're going to be like, you didn't show us how to do this. And I'm going to be like, you're right.
And I said, then it'll be great, and you will be like, oh, I guess we won't have to do that.
Oh, you guys have such awesome hopes and dreams. I hate to take them away from you. Okay, we'll go over there in a minute. All right, let's take a look at number 2. Do I have a common denominator? No. We didn't think it'd all be like number 1, did we? No, we had hope. Yeah, you can hope. Every time I watch Titanic, I hope it doesn't hit the iceberg. But guess what? Guess what happens every time? All right, this one, let's factor it. What times what gives me x squared? Okay, I need 2 magic numbers that multiply to negative 4 but add or subtract to 3.
Negative 1 and 4.
Negative 1, positive 4. Okay, so I'm going to remove this as my denominator. I'm actually going to stop and do the undefined piece real quick. Okay, so what can x not be? Survey through all your denominators. What can't x be?
1
And negative 4. Okay, so that part's done. Now, we need a common denominator. This one has an x minus 1 and an x plus 4. This one only has an x plus 4. So I'm going to leave the first one alone what does this second denominator need? X minus 1. Now, I can't just magically say, here you go, denominator, have an x minus 1. What else do I have to do? Multiply it to the top to keep it equal, right? Think about this as a fraction. X minus 1 over x minus 1 is what if you reduce it? 1. So truly, I'm multiplying by 1. All right, here we go. The numerator of this fraction is going to stay x minus 3. The denominator, x minus 1, x plus 4. Plus, I'm going to multiply this in. 2x times x, 2x squared. 2x times negative 2, or sorry, negative 1. Negative 2x. Sorry, I'd already done the multiplication in my head and just said that out loud. Okay. All right, so I'm here. Are we ready to add now?
Yes.
Yes, I regret my choices that I didn't put them in the same order, but that's neither here nor there, and I wrote in pen. All right, so in my bottom of my fraction, I have an x plus 4 and I have an x minus 1, and that carries through. In the top, is there any like term I can combine with 2x squared? No, bummer. X, take away 2x leaves me with what? Minus x. Negative 3, and, oh, nothing. Just negative 3, yeah? Yeah. Okay. Let me take a second and see if I think we can factor this further. Hold on. Well, you know, I'm not entirely sure, so I want to just double check. This is going to be, ooh, no. No, that one's not going to factor anymore. So I was trying to factor the top to see if it was going to factor into a trinomial where something would cancel with a denominator, but it doesn't. So again, always be on the lookout that maybe something can cancel, because if it can, we have to cancel that out. Okay. Come down to number 3. X plus 2. What do we know about this denominator if I factor it? X plus 2, x minus 2. Okay. So what does my first fraction need to make it have a common denominator? Yeah, let's multiply by an x minus 2, and if I do it to the bottom, do it to the top. Okay, so x times x is x squared. X times negative 2 is negative 2x. In the bottom, I have x plus 2 and x minus 2. I'm not going to take 2 steps here, because what do I just need to put at the end? Negative what? Negative 8. Okay. This one I can factor. You ready? Does the top look like a trinomial to you? Okay, so leave the bottom factored. It never helps to multiply out the bottom. That's another good rule, and I wish I would have said that earlier. Multiplying out the bottom never does anything for you. Don't do it. All right, in the top, x times x is x squared. What multiplies to negative 8 but adds or subtracts to negative 2? Negative 4 and positive 2. Okay, do you see why we needed to do that now? What can cancel? Yeah. So x minus 4 over x minus 2 would be my final answer. Let's go back and say what x can't be. X cannot be what? So go back to this step before we canceled. Yeah, x cannot be plus or minus 2. You need to go back before you cancel, because anything that was in the denominator along the way that could be 0 is problematic. So if you don't go back to this step, if you just look at your answer, you say, oh, x can't be 2. Do you see? You've got to go back and make sure you account for anything else that x can't be along the road.
Did you simplify it to negative 2 over 1?
No. They aren't being multiplied. That sounds lovely, but no. I'm all for condensing when you can condense, but this isn't one that can go further. Okay. Before we move on to my bonus example, I want to mention one other thing. Let's pretend for a minute that we had had something like this. Do you see how I can't factor either one of these? Okay. So in order to get a common denominator, sometimes, it didn't happen in either of these two problems, but it could happen. I would have to, in this situation, give this one an x plus 3. And what would I have to do to this one? Yeah. So I'd have to multiply them both by something. So when in doubt, multiply the denominators together, and that's going to give you your common denominator. Okay, so just a heads up that that could happen where you're like, oh, nothing is in common, now what do I do? Well, now, since you have nothing in common, you've got to deal with that problem and multiply each. Okay, let's see what I want. I want 4a squared b squared plus okay. Add this as your problem. Do you see how this one's different than all the other ones we've done as well? Do you see how it's different because there aren't multiple terms, right? Like we had a lot of stuff going on and now we just have single terms. So take a look at your denominators. What does this denominator need to be the same? Times 2. Yep, we need a 2. What else do we need? Another a and another b. So if I multiply it to the bottom, I have to multiply it to the top as well. So this one's going to stay the same, 16a over 4a squared b squared. This one is going to become 4a squared b squared. What am I going to end up with in the top? Yeah, good. All right, so now let's add them together. Are these like terms in any way? No, so there's not really much I can do there. Now, do you notice though that all of my coefficients are divisible by 2? So that I am going to simplify. How many times does 2 go into 16? 8, 5, 2. So my final answer would be 8a plus 5ab cubed all over 2a squared b squared. Ooh, I can even take out one more thing. Do you see how they all have an a? Okay, let's take out one of the a's from everybody too. Boom, boom, boom. So this would be my final answer. So Andrew, that kind of almost goes along with what you were asking me about on the last one, like what can cancel and what can't. The only time you can cancel stuff, like I can't cancel those 2 x's, but I could if everything had an x. So everything needs an x, or everything needs to be divisible by 2, and then you can cancel more.
So you can't cancel any of the b's?
No, because this one doesn't have any b's. They all have to have whatever it is. A multiple of 2, an a, whatever, to be able to cancel. Good? Okay. If we think about this one, in terms of undefined, it would just be a can't be 0 and b can't be 0. Because if a is 0, it would make that whole denominator 0, and same for b. All right. Are you ready for homework? Yes, no, maybe so? Sure. Okay. So tonight you only have addition ones, just like what we had in the notes. So tonight's homework is page 463 to 464. Numbers 1 to 4, 6, 8, 22, 24, 26. I had to pick through and pick all my addition friends. Subtraction's not going to be much trickier tomorrow. The only extra degree of difficulty it's going to add is that we're going to have to distribute it.